Nestled within Teri's lush green 100-acre campus at Gwalpahari in Gurgaon, the retreat complex is a shining example of Teri's dedication to research and practice of sustainable habitat design and construction. Up to the mid-90s, the Teri campus was barren and unproductive land. Today, this entire land area is covered by dense, fully grown trees and lush greenery. The whole campus demonstrates efficient and sustainable resource utilization. Efficient intra-site planning of transport, integrated waste management, and proper harvesting and husbanding of water resources assist nature in creating a unique biosphere reserve. Carefully nurtured avifauna is being preserved in an area sanitized as a nature park. The Retreat Building Complex, a residential training facility, uses minimal resources to meet its energy demand. The small quantity of waste produced in the building is recycled through organic means and then reused. And yet, this resource-efficient Teri retreat for environmental awareness and training provides all the comforts of any modern building. The complex consists of 2 semicircular blocks arranged one behind the other, comprising 24 single-occupancy rooms, 6 well-appointed suites, conference centers, a dining room, a lounge, a library, and recreational facilities. Use of shading devices and appropriate landscaping by using deciduous trees along the south shade the building facade with their lush green foliage in the summer months. During winter, they shed their leaves, allowing the sun to penetrate and heat the building. Use of insulation on vertical walls and roof, finished with China mosaic flooring on the roof, has drastically reduced the building heating and cooling loads. Through the provision of daylight-friendly design features, the need for artificial lighting in any of the rooms has been virtually eliminated. Appropriate passive solar design concepts were combined with efficient space conditioning and lighting design to bring down the connected load from 280 kilowatts to 96 kilowatts. A unique passive technique using an earth-embedded tunnel system conditions the air for the residential block. It has been scientifically proven and validated that temperature at a depth of more than 4 meters below ground is equal to the annual average temperature of a particular place. This means that during a summer day, when outside temperatures in Gurgaon go up to 45 degrees Celsius or go down to 4 degrees Celsius in winters, the temperature at 4 meters depth is a constant of 25.6 degrees Celsius, which is the annual average temperature in Gurgaon. This property of the earth has been effectively used to heat and cool the residential rooms in the retreat. There are 4 tunnels of concrete pipes laid at a depth of 4 meters below the earth. These tunnels have suction points at about 70 meters from the fan room, and 4 fans draw the ambient air through the tunnel. As the air passes through the earth air tunnel, there is exchange of heat between the air and the surrounding earth. Hence, during the summer, the air gets cooled up to 28 degrees Celsius, and during winters, it gets heated up to 22 degrees Celsius. This air is in turn circulated to the residential rooms. There are sets of solar chimneys integrated with the rooms. These chimneys are dark-colored, lightweight structures and face southwards. They absorb heat by solar radiation, and the air inside it gets heated in turn and moves in an upward direction. As the hot air leaves the chimney, it creates a draft for the cool air from the tunnel to move into the room. During the monsoons, where the humidity level is high, an additional dehumidification system is installed to remove the moisture in the air. The excess investment made in laying the earth air tunnel system was paid back during the first year of operation of the retreat through the cost of energy saved. The conference block is conditioned using CFC-free ammonia absorption chillers that run on LPG, planned to be replaced by producer gas from a gasifier in the future. Lighting loads are reduced to 1/3 of a conventional building by efficient lighting design, energy-efficient compact fluorescent lights, and T5 fluorescent tube lights. The water heating loads have been brought down to a minimum by building integrated solar water heating system with an electrical backup used only for severe winter days. The crowning glory of this modest yet remarkable building complex is the use of a hybrid power generation system, which makes it possible to disassociate the building from the power grid. The hybrid power generation system consists of 10.5 kilowatt solar photovoltaic panels along with a 50 kilowatt biomass gasifier. The photovoltaic panels also act as a roof for the lobby and the reception area of the conference block. This is the first time that building integrated photovoltaic panels are being used in India. The 50 kilowatt biomass gasifier too runs on renewable resources like briquettes made from agro waste and generates producer gas. The gas produced runs a modified generator that uses 70% producer gas and 30% diesel. A battery backup stores excess power during the daytime to be used during the night, and an intelligent building management system efficiently distributes generated electricity to various load centers in the complex. A very important aspect of sustainable building design is efficient waste and water management. All the 5,000 liters of wastewater generated daily is recycled and reused with the help of a plant species called phragmites. The roots of this plant can break down wastes into manure and grey water, which are then used for horticultural purposes. An environmentally sound, sustainable building should be economically viable, an adage amply proved by the retreat. While design interventions like proper orientation and shading did not cost anything additional, interventions like the systems involving the earth air tunnel system, efficient lighting, solar photovoltaics, and solar water heating did require some additional investment. On the whole, the retreat building incurred an additional investment of 7% over that of a similar conventional building. But by use of energy-efficient systems and devices, 40% effective savings in recurring energy costs have been achieved. With the use of solar photovoltaics, which is still an expensive technology, the building was dearer by about 30% over a similar conventional building. But 60% savings in recurring energy costs have been effected. The retreat complex has been a trend-setting model for many other buildings in the country. To mention a few, the newly constructed Biological Sciences and Bioengineering building at IIT Kanpur and the Indian Oil Corporation building at New Delhi have emulated retreat in many ways. Even in Nepal, the Center for Energy Studies, Tribhuvan University, has used several concepts applied in the retreat building. Teri has helped and guided the Confederation of Indian Industry, CII, in their Green Business Center building in Hyderabad, and the ITC in their Corporate Excellence Center in Gurgaon to get the highest award from the United States Green Building Council. Teri has been disseminating its knowledge and experience on sustainable buildings through publication of books and holding training programs for architects, engineers, and planners. With the imminent energy and water crisis looming large throughout the world, attention is urgently needed on the science and practice of sustainable building design. Teri is committed to joining hands with other organizations to make buildings of tomorrow sustainable and better places to live and work in.